All right, welcome everyone. My name is Shivansh, and I'm a AWS Senior Solution Architect here. And I'm going to talk about getting started with AWS Lambda and serverless computing. So how many of you have used Lambda or have worked with serverless? Cool. So we have a couple of folks who have worked on this. So before we get started, a little bit about myself. As I mentioned, I'm Shivansh. I'm here a Senior Solution Architect at AWS Quick Start team, and I've been working with customers on different AWS serverless technologies. I live here in San Francisco. Before working at AWS, I've been working as a senior software engineer at Intuit, and I did my master's from computer science in computer science from Northeastern University, Boston. So why are we here today? So serverless is essentially a really hot topic from last couple of years, and it's growing really fast and in a very rapid pace. So today's session is about getting started with serverless in AWS, and primarily we will focus on AWS Lambda and API Gateway. So what does serverless means? At AWS, there are 4 things which are the core pillars for serverless. You don't have to worry about managing any of your infrastructure. So no servers, no physicals, no virtual, and no containers. It automatically scales with the usage. So anytime your request comes in, it automatically grows with your request demand. And you only pay for what you use. So there is no commitment, no idle time, and you're only paying whatever you are using in terms of compute, and also the compute you are using based on the storage for your Lambda functions. And last, it's highly available and fault tolerant. So like any of the AWS services, high availability and fault tolerance is built into the serverless technologies we have here at AWS. So what does that mean for you? Basically, greater agility, less overhead, better focus. So you just focus on building your business logic and worry less about maintaining the servers or maintaining the infrastructure. It increases automatically with the scale of your application. And you have more flexibility in terms of what technologies and what services do you use. And that ultimately brings down to faster time to market your application. So at the center of serverless technologies here at AWS, Lambda is the main focus. So we're going to highlight, we're going to talk about a lot in AWS Lambda, and also we will focus on Lambda functions as well as API Gateway. So there are servers behind serverless, but when it comes down to you, it essentially means that you only focus on building the serverless application using and focusing on your business logic. For you, you don't have to worry about maintaining the servers, creating virtual machines, or creating the containers, or managing the fleet of servers. So Lambda is at the center of few different trends and terms, as you can see here. Event-driven compute, function as a service, and serverless functions. And all the 4 pillars which I mentioned before, it's all built into Lambda, which I'm going to talk about a little bit more in detail in next couple of slides. So today, we will show how Lambda transparently supports load balancing, auto-scaling, and handling failures while preserving security isolation and utilization. So let's talk about building a serverless application. So when you are building a serverless application, you are primarily, there are 3 sections. Your Lambda function, which you can use any programming languages such as Node.js, Python, Java, C#, Go, Ruby, and you can also bring your own custom runtime. And I'm going to talk about a little bit more in detail how you can bring any of your custom programming languages and use Lambda function to build your application. Now, once you have your application business logic built into Lambda function, how are you going to invoke that? And there are a couple of ways you can do it when you are using Lambda function. And that we call it event source. So you can invoke your Lambda function when there's a change in data state, or you can directly invoke Lambda function endpoints directly either through Lambda endpoints or API gateway endpoints. And I'll show you in a little bit how you can actually create API gateway endpoints and how you can invoke your Lambda function. The third is also you can invoke your Lambda function based on the change in the resource state. And the third section you see here is basically your Lambda function calling external services or any HTTP or HTTPS endpoints which are available on the internet. We will not focus a lot on the third part of it, but we will have our focus mainly on functions as well as the event source. All right, so let's get into the demo. So here, I'm on the AWS Management Console. And the way you create and navigate through the AWS console to create a Lambda function, you basically search for AWS Lambda. And you are directly moved into the Lambda console. So make sure you select the appropriate AWS region. So right now, I'm in right now in US West 2, and I'm going to keep that and click right on the create function. So you have a couple of options to create a Lambda function. You can author from scratch. So it's going to create a template for the Lambda function, and you're going to have all your business logic writing from the scratch. We also have some of the blueprints, so you can actually get started with creating a Lambda function with some of the boilerplate code, which will help you get started really quickly. So I'm going to create a Lambda function from scratch and call it AWS Loft Lambda. You select the runtime, so I'm going to use Python 3.7. But you can see here there are different programming languages available for you to use for your Lambda function. And within each programming language, you have different versions of it. So each Lambda function requires a role to actually execute the Lambda function and which services it can use while execution. I'm going to talk about the security model of Lambda function a little bit more detail. So right now, I'll say choose existing role and select one of the IAM role, which is Lambda Basic Execution. Click Create. And I have my Lambda function created. As you can see here, it automatically gives me a code, which is basically a Lambda handler. And I'll dig deeper into what exactly this Lambda handler means. But this is kind of a hello world program for Lambda function. So to be able to test it, I'll create a test event on the top right corner. Give my test event a name. So I'll give AWS test event and click Create. And click Test. So you can see that it executed correctly, and there's a green check mark, and I can see the details of the logs in the execution output. So this basically gives you a high-level overview of how you create a Lambda function through the AWS console and how you navigate in the AWS Lambda console. So when we talk about AWS Lambda service, we primarily talk about Lambda function. And that's the unit of deployment and the model you think about in terms of configuration your Lambda function. So when we are talking about Lambda function, there are primarily three things: your handler function, your event object, and the context object. So the handler function is basically the entry point for your code. As you can see here, we are defining the Lambda handler, which calls Lambda handler, and we are passing event object and context object. And everything we do inside is essentially, it's up to you based on your business logic. You can create a different function which is called from the Lambda handler, and you return the output from your business logic back to the AWS Lambda service through the Lambda handler. Now, event object is, as the name suggests, it contains the information about the event source. And event source depends upon the event which is invoking your Lambda function. So if you are calling Lambda function from API gateway, it's going to have a different event object than when you are invoking a Lambda function using a trigger of S3 bucket. The third thing is, which we are passing to the Lambda function, is the context object. And the context object is another object which is available for your Lambda function, which provides information about the execution environment. So such as the request ID, log group, and more information about what kind of execution environment you are using. Now, some of the things we have seen customers doing is a lot of times when you create a serverless application, you are reusing your code. So there are some utility functions and some of the business logic which are being used across multiple Lambda functions. So earlier, before we announced Lambda layers, what customers were doing, actually, you have to package the Lambda, the common code within your deployment package for each Lambda function, which kinds of make your Lambda function bulky as well as it's unnecessary. So we launched Lambda layers for that. And what you can do with Lambda layers is you can create you can put the reusable code of your Lambda function, which you're going to use with multiple Lambda functions, and zip it and create a Lambda layer, which essentially helps you to actually separate your business logic from the reusable code or the utility functions which you are using within your serverless application. So some of the details about the Lambda layers, you can zip your common code within the deployment package and create a Lambda layer. And the Lambda layers are immutable, but they can be versioned to manage updates. So what does that mean with the immutability is if you created a layer and you deleted that layer, your Lambda function which is using that layer will continue to work, but you won't be able to create any new Lambda functions with that layer. And the limit, sorry? Yeah, I'll give a little bit more detail into the rest of the presentation and towards the later if you have any questions. And another limit you have with the Lambda layers is you can create up to 5 Lambda layers for now, including your custom runtime API, which I'm going to talk about in the next slide. So as I mentioned before, you can bring any custom programming model and which are not directly supported by AWS Lambda using Lambda layers. So let's say there's a programming language you want to use which is not directly supported by AWS Lambda, like which you see in the console when we were creating the Lambda function. You can bring the runtime APIs and that programming model and package it as a Lambda layer and create a layer. The only restriction is it needs to be compatible with Amazon Linux, because that's what we use underlying for runtime APIs. So the way you can actually create the custom runtime API is you have to create a Bootstrap file, which is an executable file which acts as a bridge between the runtime HTTP API and the function, your Lambda function, which needs to be executed. So the Bootstrap needs to manage the response and error handling, the context creation, and the function execution. And the information on the interface endpoint and the function handler are shared as environment variables when you are using the runtime Bootstrap. So if you are, the way it's going to work is when you invoke your Lambda function, it's going to get an event. So the Bootstrap will get an event. It will propagate the tracing ID to your Lambda function. It will create a context object. And then it will invoke your function handler, which you have defined in your Lambda function. The function handler will receive the event and context object. It will execute it. It will return the response back to the Bootstrap. And the Bootstrap needs to handle that response, handle any errors which happen within your Lambda function, and then also do the cleanup. So cleaning up like any resources you have opened or any connections you have opened, that needs to be done by your Bootstrap as well. So essentially, it's acting as a bridge between the HTTP API and your function. Now let's talk about the pricing model of Lambda function, which primarily depends on two things: the memory you are choosing for your Lambda function and the compute time of your Lambda function based on how much you are running your Lambda function longer. So the compute time of your Lambda function is in 100 milliseconds increment, but there is no commitment for using the Lambda function. So if you are using a Lambda function for whatever minutes, you pay based on that and based on the memory you have selected for your Lambda function. So there's no hourly charge, no daily charge, no monthly charge, and no minimums for using or creating an AWS Lambda function as well. There's no per device fees, and you never pay for your idle Lambda function. Now, when tweaking your Lambda function for power or how much memory you use, there's essentially only one knob to be able to tweak your Lambda function. And that knob is basically you are selecting how much memory you want to allocate to your Lambda function. The percentage CPU as well as the network capacity is automatically provided based on the memory you choose for your Lambda function. So you don't have to worry about having multiple knobs and having managed between, okay, how much CPU you want to provide to your Lambda function, or how much network bandwidth you want to provide. Now, there are a couple of execution models when it comes down to Lambda. As you can see here, the first is the synchronous model, which is also called a push model. So let's say you have a Lambda function, and you created that Lambda function behind Amazon API gateway, and your request comes in to the /order endpoint, which invokes your Lambda function. In this case, it's a push model, and it's a synchronous model because your Lambda function needs to return back the response back to the API gateway. So it's a whole round-trip invocation. The another execution model is the asynchronous model, which is an event-driven model. So if you have an Amazon SNS topic or Amazon S3, if there is a change in if there's a message to the Amazon SNS topic, or is there a change in the object of S3, it can invoke a AWS Lambda function. And in that case, your Lambda function does return a response, but it does not return, or it's not waiting for the response back to the S3 or SNS. So it's only one way. And that's basically an asynchronous or event-driven model. The third execution model is the poll-based model. So for example, if you have an Amazon DynamoDB streams, or you are using Amazon Kinesis stream, if there is a change in the stream, or if there are any activity happen, for example, in your Amazon DynamoDB table, and you have a stream created for your table, the stream is going to get that information, and there's a Lambda service which is polling that stream and execute your Lambda function. So that's the poll-based model. AWS Lambda also provide the APIs. So if instead of directly using using the API gateway, you can directly invoke Lambda functions through the Lambda API. And these are used by all other services to invoke the Lambda functions within the ecosystem. It supports synchronous and asynchronous both. And you can pass any payload directly to the Lambda function when you are using the Lambda API. Now let's talk about the security. So security is our #1 priority at AWS, and it's no exception with AWS Lambda as well. And security is deeply ingrained into AWS Lambda. There are primarily two models when it comes down to security in Lambda. First is what the Lambda function itself can do when you are invoking a Lambda function. So for example, can Lambda function get an object from S3 bucket? Or can a Lambda function write to a DynamoDB table? That's called execution policy. The second aspect of it is the function policy, which is basically telling who can invoke your Lambda function. So if an API gateway can invoke your Lambda function, or if your Lambda function can be triggered through S3, change in the S3 object. And that basically is the function policy. So it gives really fine-grained control over what your Lambda function can do and who can do with your Lambda function. Now, there are a couple of common use cases we have seen across how Lambda function is being used, and which primarily falls into these 6 categories. First, web applications. Customers use Lambda for various different use cases for creating static websites, complex web applications, or packaging for Flask or Express frameworks. The another use case is creating the application backend, such as mobile backend or IoT applications, and using Lambda function for the IoT application backend. The third use case is data processing. So whether it's real-time data processing or batch data processing or doing a map reduce using Lambda function. Customers also use Lambda function for chatbots. So they have the chatbots created for their business, and they use Lex along with the AWS Lambda to create the backend for the chatbots. Lambda is also core part of Amazon Alexa. So a lot of skills which you see with Amazon Alexa are backed by AWS Lambda functions. Lambda is also used primarily in IT automation. So for policy engines or creating or doing any action or executing any action based on alarms and monitoring is also very much used for the IT automation use cases. Now let's switch some gear and talk about another service within the serverless ecosystem, which is Amazon API Gateway. As the name suggests, it's an API gateway, which is a unified API front end for multiple services, such as microservices or monolithic services. It automatically provides a DDoS protection and throttling for your backend. It also has a way to authenticate and authorize requests to your backend, whether it's Lambda function or anything else. And you also get to throttle or meter and monetize your APIs for the third-party developers when you are using Amazon API Gateway. Now, when you use Amazon API Gateway, there are 3 primary ways you can use it. First, we call it edge endpoints, which basically you use Amazon API Gateway along with the CDN, which is Amazon CloudFront service. The second way you can use Amazon API Gateway, which is called regional endpoints. So you can have your endpoints created using Amazon API Gateway, which are available within an AWS region. So it could be any other application which is available in the same region for your business, and you only want to use within that AWS region. And the third is the completely private API endpoint for your backend services within your VPC. So you have your application, and you have an endpoint created for your application, and some of the other components of your application wants to call that, then you don't need to go all the way to the internet. You can use the private API endpoints for that. Now, there are a number of technologies which can run code for your API gateway when you are actually behind the API gateway. Of course, we saw how you can use Lambda functions behind the API gateway, but you can also use any HTTP endpoint you are running on EC2 or Elastic Beanstalk or Amazon ECS, which is our Elastic Container Service, or you can run your code on Fargate or anything which runs on Amazon EC2. You can also wrap other AWS services for your backend when you're using Amazon API Gateway. In addition, you can also use API Gateway, and you can call any HTTP or HTTP endpoints which are available on the internet. So in front of your resources within your VPC, you can also use Amazon API Gateway. So for example, in this diagram on the right-hand side corner, you can see that you have your endpoints running on your Amazon EC2 instances, which are private, and you can call those endpoints from your Amazon API Gateway endpoints. Now, recently we also introduced something called as API Gateway WebSockets. Using Amazon API Gateway WebSockets, you can build real-time two-way communication application, so such as chatbots, alerts and notifications, and streaming dashboards. And again, API Gateway is a fully managed service, so which gives you to handle connections between your application and transfer messages using the fully managed API using API Gateway WebSockets. You can invoke these API Gateway WebSockets using different AWS services such as Lambda, Kinesis, or other HTTP endpoint-based message content. And also, when you are using API Gateway WebSockets, you only pay for what you use. So primarily, you pay based on two things. One, you pay for your connection minutes and the messages transferred using those calls. Now, let's talk about how some of the customers use and build their serverless web applications using AWS Lambda, AWS API Gateway, and some of the other services within the serverless ecosystem we have here at AWS. So as you see in this diagram here, you have your static pages on Amazon S3 bucket, and those are connected to Amazon CloudFront and served through Amazon CloudFront where your customers are located. And you have your backend written in AWS Lambda. And you have the Amazon API gateway, which invokes the Lambda function and execute your business logic. So when client is accessing your website, it goes through Amazon CloudFront. Any of the static content is served through Amazon S3, and any of the dynamic content or the business logic is executed through Amazon API gateway calling Lambda function. And at the back end, it could be interacting with database tables or any other HTTP or HTTPS-based endpoints. Some of the other serverless architectures we have seen customers using with different AWS services in the serverless ecosystem are these. So one you can see here on the left-hand side, the first column is you have an S3 bucket, and you have the objects in the S3 bucket. So every time there is an object is put into the S3 bucket, a Lambda function is invoked. The second architecture you could use when using Lambda function is when you are publishing messages into a SNS topic, and you call Lambda function through that SNS topic. So every time there's a message put into the SNS topic, there's a trigger which triggers your Lambda function, which executes your business logic in the Lambda function. The third is when you, let's say you are using Amazon SQS, there's a message which is put into the SQS queue. Lambda polls the queue, and it invokes the Lambda function, and the function performs some action based on that message, and it removes that message from the queue. Another way you can build serverless application is using Amazon Kinesis data stream. So you have multiple devices or other applications which are putting messages into the Amazon Kinesis data stream, and the Lambda function is invoked through that data stream. As it's polling your Kinesis data stream, it executes the Lambda function, takes some action based on that, and return back to the data stream. Another example, as I mentioned before, customers use chatbots, and they use Lambda function to actually perform some backend execution. So you have a chatbot which have some conversation need, so it talks to Amazon Lex, which is another AWS service, and it invokes Lambda function to take some action based on the chat messages. Another way you could use AWS Lambda is through CloudWatch events. So you can schedule the Lambda function to be invoked at certain time through the scheduled events within your CloudWatch logs. Now, what we have seen from working with many customers is they do a lot of orchestration within the Lambda function. So they do if and else to take some decisions or perform some exception handling, catching errors, and also they do wait or sleep within the Lambda function, which essentially, if you think about it, the pricing model we have, is a very useful way of using Lambda function, because you are still paying for that idle minutes while you are waiting or while you are sleeping within your Lambda function. So we have another service which is called AWS Step Functions. With Step Function, it's essentially workflow management with zero administration. So what Step Function provides, it provides different states or different tasks for your Lambda function. So for example, as you can see here, there's a task state, there's a choice state. What you can do using that is within the task, you can perform any actions. With choice, you can make if and else decisions. And you can also perform parallel tasks or do failure handling using Step Function. So which makes it really, really easy to coordinate the different components of a distributed application which you are building. So each box you see here, like extract, image metadata, image type check, every green box you see here is each a Lambda function. And essentially, you are doing the management of the workflow through this step function by just defining different choices, different parallel tasks, or another failure capture task. Now, all the services we have here at AWS, like AWS Lambda, Amazon S3, Amazon CloudFront, Amazon DynamoDB, Amazon Kinesis Data Stream, Amazon Cognito, Amazon SNS, all are, you can use all of these services to build PCI and HIPAA compliant serverless applications. Now, the question is, how do you start, or where do you actually start with using the different services or AWS Lambda and start building your serverless application? One of the things I always recommend to the customers is start with the framework. We have a lot of different frameworks built by AWS, but we also have a lot of third-party frameworks which can help you get started with building serverless application. At AWS, some of the frameworks we have is AWS Chalice, AWS Amplify, AWS SAM, which I'm going to talk about a little bit in more detail. But we also have some of the third-party serverless framework which are really popular, like CloudWatch.js and Serverless Framework. Now let's talk about SAM. As you can see, a little cute squirrel friend here, which is our mascot for AWS SAM, which SAM stands for Serverless Application Model. So it's basically an extension for AWS CloudFormation, which is optimized specifically for building serverless application. What it provides is basically spatial serverless resource types. So you can create functions, APIs, tables, and serverless AWS layers using SAM template. We have open sourced the specification for SAM, and you can get more detail in awsamazon.com/serverless/SAM. Now, let's take a look into how the SAM template looks like. So primarily, it has 3 different components. On the top, you see is a header, which is AWS template format version. The second is transform, which tells what exactly this template is about. So it tells CloudFormation that it's not a regular CloudFormation template. It's a serverless template which needs to be transformed into the CloudFormation resources. And the third, which is the crux of this SAM template, is the resource section. You can see here there are 2 different resources. One is get HTML function, and the second is list table. List table is a simple resource which creates a DynamoDB table with 5 read and write units by default. And the second resource is get HTML function. What it does, it creates a Lambda function which is and provides some of the properties such as code URI, which tells where the Lambda function zip file is, what is the name of the handler, what is the runtime, in this case it's Node.js 6.10, what policy this Lambda function is going to use, and it also creates an API gateway endpoint with the path as /proxy and method as any. So if you see here, just the 20 lines of code actually reduces and helps you to create these many resources for you. So if you want to create these resources in a regular CloudFormation template, you have to write anywhere around 80 to 100 lines of code, which in SAM, it makes it really easy, and you can achieve in like almost 15 to 20 lines. So this is another example you can see for the SAM template. On the left-hand side, you see from line 9 to line 25, it's actually creating 7 different AWS resources, which you can see on the right-hand side in the picture, which makes it really, really simple to create different AWS resources using SAM template. So we also have SAM CLI, which is our command line interface, which you can use on your local machine or your local development environment. And it helps you to develop, debug, test, deploy, and monitor your serverless application. What it helps you to actually is really fast pace your development when you are doing it on your local machine. So it uses Docker to actually create the execution environment for your Lambda function or on your development machine. It deploys the code in that execution environment. It executes it. And if you're using API gateway, it will also provide an API endpoint. And you can also use CLI to actually generate the payload for your Lambda function automatically. So it makes it really, really easy to give you the whole picture of running a Lambda function and creating a Lambda function on your local machine. You can get more details on SAM at awsamazon.com/serverless/SAM. So another thing we have within our serverless ecosystem is serverless application repository. And this is basically a central place to discover and deploy and publish serverless applications. And also, this is a really easy way to actually start exploring different serverless applications. Every time if you have any example you want to see how to do something, I think this is a really good place to actually go and explore and see how others have contributed and how others have built serverless applications using different services. Now let's talk about some of the other capabilities we have in the ecosystem, that is metric and logging. And as we say here, metric and logging are a universal right, and it is no different for Lambda and API gateway. We have CloudWatch metrics directly integrated with AWS Lambda, and we have, by default, 7 built-in metrics for AWS Lambda: invocation count, invocation duration, invocation errors, throttle invocation, iterator age, dead letter queue errors, and concurrency. You can also create your own custom metrics using CloudWatch CloudWatch metrics by using the API called putMetricData. There are 7 built-in metrics for API gateway: API call counts, latency, 400 errors, 500 errors, integration latency, cache hit count, and cache miss counts. You can also have CloudWatch logs. So when you are using API gateway logging, you automatically get error and info logs for your API gateway. Optionally, you can also log request and response body content, but I will be careful about doing that if you really have a large payload, because it can really cost you a lot if you have a really high traffic API. We also have logging directly integrated with AWS Lambda. So you can automatically get the logs in the CloudWatch logs by creating the console.log or any other log equivalent of that in whatever language you are using for your Lambda function. Some of the basic information is automatically provided when you are using CloudWatch logs for your Lambda function, but you can log anything like you use any programming language like printf, or you can write any commands as you use for your different programming model. We also have something called as log pivot. So when you are building the metrics, actually when you are using the log pivot, you can build metrics based on the log filters. So you can provide the filters which you want to filter into your log, and it will automatically generate the metrics based on those filters. And you can also export those logs to AWS Elastic Cache or S3, and you can explore those logs using Kibana or Athena or QuickSight. Now, one other component which I would like to talk about is AWS X-Ray. Now, when you are doing debugging or troubleshooting your serverless application, AWS X-Ray is a really useful service. It allows you to capture information from inside the Lambda function and execution of the Lambda functions. There are two basic things about AWS X-Ray integration. You can enable tracing for your function. So as you can see here, you can do that by clicking that checkbox when you want to enable X-Ray integration tracing. And then you can also, inside your function, optionally include X-Ray SDK that allows you to capture detailed information about the calls within your Lambda function. And you get this awesome diagram which shows you how your clients are calling your Lambda function, how many successes and failures, and what are the external calls your Lambda function is making to either AWS, other AWS services or other HTTP endpoints. It's a really powerful tool when you are doing debugging and troubleshooting of your serverless application. And whenever I'm talking to any of the customers, and the first thing, if they want to do any troubleshooting, is I recommend them to actually enable AWS X-Ray. Another thing you get with that is this really awesome water flow diagram of the flow of the application. It is really useful when you are troubleshooting and you want to see which components within your serverless application is slow or responding or slowly or taking more time. Now, if you want to understand more about what are the different resources we have available at our serverless ecosystem at AWS, you can go to this page, awsamazon.com/serverless, and it will give you more information, and you can learn more about different services we have at AWS in serverless ecosystem. You can see in the center bar, you can look at the serverless application repository. You can also see what are the developer tools we have and other resources and some of the partners we have who are working and building capabilities on top of different AWS services. Again, thanks for coming. My name is Shivansh, and if you have any questions, you can follow me on Twitter. My handle is Shivansh_Singh. And thank you very much. So, any questions?
You were talking about the time management, right? With the Lambda, they cleared cover part of the time management with Lambda functions can run not run more than 5 minutes. So is it like you said there is a provision to extend it more or something?
Okay, so just for the live stream, the question is the time, how much you can run your Lambda function, and is there a way to extend that? So right now we have around, each Lambda function can run for 15 minutes. There's no way you can go beyond that, but the way we have seen customers using Lambda function is you have a limit of 15 minutes to run each Lambda function. Yes? Sorry. So your question is about how do you tune your Lambda function?
Also, how you use the free tier of 400,000 gigabytes. What are you measuring to make that 400,000 gigabytes?
Right. So your question is about tuning your excuse me, tuning your Lambda function and also using the free tier for that 400 gigabit per customer per month you get. It's gigabits. So so right now there is single knob to actually tune your Lambda function. And essentially when you create a Lambda function, you have memory which you allocate to your Lambda function. And based on how much memory you allocate to a Lambda function, it automatically allocates the corresponding CPU and network bandwidth for that Lambda function. Now, for the payment side of it, you actually pay for the compute time or the runtime of your Lambda function, as well as the storage. So that's the combination of what you pay for your Lambda function. Does that answer your question?
The second part, you're actually measuring the amount of network bits, right? I thought
Yeah.
storage or memory use, that's what confused me.
I think I can answer your question later during the workshop. I need to look into what exactly your question is about the network bandwidth, and I can help you calculate that if you have any specific use case. Okay, yeah.
Is there a performance penalty for using a Lambda layer as opposed to just a regular query?
Performance penalty?
Well, because, I mean, the whole Lambda layer thing confused me. I'm assuming that that's something you can like have shared libraries or whatever that you have different systems calling into. Is that, I guess my question on that is there a performance penalty for using that in conjunction with the function rather than just having everything?
No, so there is no penalty or anything. Essentially, when you are using a Lambda layer, you actually, the combined store, sorry, the total limit for your package, the deployment package, is including your Lambda layer. So for each Lambda, it's not just the Lambda function, it includes all the layers as well. So you have the limit for the whole layer. Okay, I think we'll wrap up here. We have a couple of minutes, so if you want to take a break, go for it. But we will start the workshop at 11. And if you have any more questions, we can, myself and my colleagues will be available here. We will be walking around, so we can help you answer those questions as well. Thanks.